here? Oh, there we go. Can you hear me now? Of course you can. Thanks for coming. It's a big rollout. I'm impressed. Anyway, we're going to give you an update on Wolbachia. Basically, I've been working at JCU for quite some period of time and worked on dengue. Before then, I worked at Queensland Health and worked on dengue control. And we used to get a lot of dengue outbreaks. Anyone might recognize Denby Street. Yeah, Parramatta Park. And those old Queenslanders, cheek to jowl, those were dengue hotspot in Cairns. We used to get dengue outbreaks literally every year in the summer. And some of them got up to 1,000. Time out, something isn't working.
Sorry.
Oh, am I too loud? Oh.
No. Most people cannot see it.
Oh, they can't hear me. Do I have to start all over again? Nah, that's good. You missed it. You missed the punchline. Anyway, we used to have a lot of dengue. And dengue is basically fever, rash, headache, muscle ache, vomiting, feeling really bad, very tired, fatigue. Generally not fatal, but it can be. It can develop in rare cases in what they call dengue hemorrhagic fever, where you get plasma leakage, bruising, hemorrhage. And that's probably only in about 1% of cases. So we don't see it much here. We used to just get classical dengue fever here for the most part. But if you do get DHF and it's not treated appropriately, up to 5% of those cases can die. And dengue has 4 different serotypes: dengue 1, 2, 3, and 4. So you can get dengue 1 and then a year later you get a different serotype. And usually when you get what they call a secondary case of dengue, it's usually worse, higher risk of dengue hemorrhagic fever. It's almost like the immune system's been primed, and it is treatable by fluid management. So Aedes aegypti is the mosquito we're going to be talking about. It really is a great vector. It's what Queenslanders call the dengue mozzie football socks. I call it the cockroach of mosquitoes because it's domestic, lives around the house. I got them in my house, and they feed almost exclusively on humans. And because they're around humans, they've learned to avoid the slap. Otherwise, they'd be dead. And that means they're very quick. And so one mosquito, he may go and bite several people in order to get a full blood meal. That means he can spread dengue to multiple people in the same household. And you get explosive urban outbreaks and epidemics because of that behavior. Dengue is a tropical disease, and North Queensland has it, but it's all pantropical. And it has steadily increased in the last few decades. This is a bit of a dated slide, but it's still going up. I think they estimate somewhere in the order of about 400 million potential dengue cases a year. And then, of course, we've got Zika. In 2016, Zika arrived on the scene. And we know how tragic that was. It, too, is carried by Aedes aegypti. So all of a sudden, there's different diseases being carried by this mosquito, and everyone got a little bit panicked, I have to admit. So anyway, this is Wolbachia. I know some of you have seen this, but some of you haven't. So I thought this is probably the easiest way to explain how Wolbachia works in the history, brief history of the program.
The mosquito known as Aedes aegypti originated in Africa. Over the last 400 years, it has spread throughout all tropical regions of the world, transmitting viruses to people. We are working on a way to stop this mosquito from transmitting dengue. Our method uses naturally occurring bacteria called Wolbachia that live inside insect cells and are passed from one generation to the next through the insect's eggs. Wolbachia are found naturally in up to 60% of all the different species of insects. Insects that include fruit flies, moths, dragonflies, and butterflies. The secret to the success of Wolbachia is how it manipulates the reproduction of the insects it lives in, so to give itself an advantage. It works like this. If a male insect has Wolbachia and mates with a female that doesn't, then the eggs she lays won't hatch. If the female has Wolbachia and the male doesn't, she would lay her normal number of eggs. They would all hatch, and all offspring will carry Wolbachia. When two insects that both carry Wolbachia mate, the eggs will hatch, and all offspring will carry Wolbachia. Over a few generations, the number of individuals carrying Wolbachia increases rapidly until nearly all the insects within a population have the bacteria. We wanted to see if we could use Wolbachia as a way to stop dengue transmission. To do this, we first had to move Wolbachia into the mosquito so that it would grow and be passed between generations. Using microscopic needles, we took Wolbachia from the fruit fly and injected it directly into young Aedes aegypti eggs. It took us thousands and thousands of attempts, but finally, we were successful. We then took the mosquitoes that contained Wolbachia and infected them with dengue, and found something really exciting. The virus didn't grow well in the mosquito, and if it can't grow, it can't be passed between people. Our next step was to build large enclosed outdoor cages in northern Australia that we filled with local mosquitoes. We then introduced mosquitoes containing Wolbachia to see if it could spread into the cage population, and it did. We now wanted to test the method where dengue is found, but before we did this, we needed the government to examine the safety of our method and approve our trials. Then we needed to gain the support and approval of communities to release mosquitoes containing Wolbachia. With these approvals, we began our first open field trials in Australia in 2011. Wolbachia mosquitoes were released once a week for 10 weeks, and within a few months, close to 100% of the mosquitoes had Wolbachia. And years later, they still do. Ongoing trials in Australia and dengue endemic countries are now determining the best way to deploy Wolbachia across whole cities. It is our hope that with continued success, the Wolbachia control method will protect the health of the 2.5 billion people that live in dengue transmission areas.
Yes, my hand's a bit wore out after that. But yeah, this was Bill and Melinda at a more pleasurable time for them. And that guy on the right there is Scott O'Neill, who's been the director of Eliminate Dengue, and now it's called the World Mosquito Program. And the fellow in the background is Ari Hoffman, and he's been a big part of this sort of brain stress over the year. And those are cups of mosquitoes that we're going to release, adult mosquitoes, okay? And Gates was a big founder of this through the grand challenges in global health. But we've had other founders too. When Zika came along, all of a sudden people started opening up money on this, including Queensland government. So it's been a ride, let me tell you. So basically that program, one of the first things we had to do was we had to do a lot of community engagement. So you're convincing people who've been told for years to tip it up and throw it away, or you could be fined for breeding mosquitoes. And now we're coming around, we're telling them, oh, we want to release mosquitoes outside your house. So that took a lot of sausage sizzles to get that approval. And the very first place we released mosquitoes at were two places, Yorkeys Knob and Gordonville. And Gordonville was where the cane toad was released. So people there were pretty skeptical of the whole thing, but we got it done. And basically the Wolbachia program had 4 steps. First of all, we had to rear them, and we reared them over here at James Cook University. This guy right here, you'll see his photo here in a minute. Then once you reared the mosquitoes, we released them. And at this time, we were releasing cups of adult mosquitoes. We might have 100, 150 mosquitoes in there. Then we set mosquito traps. So this is what they call a BG trap, BG sentinel trap, this thing down here. It's nothing more than a sort of a collapsible laundry hamper. It's got a little black cone on the top. It's got a fan in the bag. So the mosquitoes love black. It's shady, it's quiet, it's humid. And they're attracted to that black, and then they get sucked down and collected. Then we've got to PCR those mosquitoes looking for Wolbachia, because the goal of our thing is to get Wolbachia up to nearly 100% in the mosquitoes if possible. And at JCU, we were producing at that time up to 70,000 Wolbachia infected mosquitoes a week, but we've produced a lot more than that now. I think we produce, do you have any idea the top amount we ever produced in any of these programs was, Mick? I know it was 250,000 one time. So it can rear a lot of mosquitoes. And then we had to sustain that for this is Claire Odenay, by the way. And the way we blood fed the mosquitoes was we had people volunteer their blood. So they would sit in a cage of mosquitoes and let them feed. And we'd pay them $20 for 10 minutes. And actually there was quite a group of people who came in there. And you see, oh, it was poor students. No, it was poor staff. And the whole idea is this, is that here the red is a wild population and the green represents Wolbachia infected mosquitoes. So after a series of releases, you get it to the point where almost all the mosquitoes are infected. And once it's over about 50%, it'll go on in naturally by itself, okay? So that is the goal. And we started out in these two areas, Yorkie's Knob and Gordonville. And this is a bit of an old slide, but I have an update. So the green here on the far left here is when we were releasing mosquitoes, and this is the infection rates in Yorkie's Knob in yellow and green for Gordonville. And you can see that it's been upwards of 90%, close to 100% for years. And they have continued to monitor, and this goes up until a little over about a year ago. And you can see it's still naturally occurring in the population. The other method that we've started using is what they call Mozzie Box. So instead of releasing adult mosquitoes, we actually go and we get mosquito eggs laid on strips from the colony, and then we put them in one of these containers. Here's a couple of them. They call this a mosquito release container. This is nothing more than a noodle box, and this is just a soda cup container. You put about ½ liter of water in there, add food, add the eggs, set it on the ground, or you can hang it up. You can hang it from a tree, and within 2 weeks, the mosquitoes come out naturally. Actually, that's worked better than adult releases. We think it's because the mosquitoes emerge and can fly when they're ready to fly. So here is North Queensland. It's a bit of a busy little graph, but each of those dots represents dengue case. And these are the big dengue epidemics that occurred in Cairns. Okay, the big one was 08, 09. That was a doozy. We had nearly 1,000 cases. And this is Wolbachia infection right here. And you can see that since we've gotten Wolbachia established, we basically have had no cases of dengue up here in North Queensland. The only exception is a couple of years ago, we had 2 cases of dengue in Townsville in an area that had Wolbachia infected mosquitoes. So it's not 100%, but boy, that's pretty close. It also works for Zika virus. So over here, we have a mosquito that doesn't have, the control mosquito doesn't have Wolbachia, and it is fed, and here's a mosquito that does have Wolbachia, and they're fed blood that has Zika virus in it in a laboratory situation. And you can see here that a disseminated infection means the virus is spread through the insect, okay? And they usually look at legs of the mosquito. An infectious virus in the saliva means that there's actually virus in the spit of the mosquito, and it can transmit a virus. And you can see this is actually one of these studies. I think, it almost looks too good to believe. So they have done other studies, and maybe they're not quite that good, but they're still pretty good. In this case, it got 100% blockage of transmission. And currently the World Mosquito Program we have like 12 different countries that we're at. So it's primarily Southeast Asia, the Pacific, and also Latin America. And recently we had a publication come out in the New England Journal of Medicine, and this described a randomized controlled trial in Yogyakarta, Indonesia, what they call an RCT, the gold standard. Just like these vaccine things, they go, we've got to have the control group, the treatment group. We did the same thing. And here's Yogyakarta. It's in the island of Java. And to the left is a big area of the city, and it's been put into 24 different clusters. So 12 matched control and 12 matched treatment. And the control had no Wolbachia release. The treatment had Wolbachia infected mosquitoes release. And here is the Wolbachia infection in the mosquitoes in the treatment clusters, the intervention clusters. And you can see that it got in steadily, and it's really at a very, very high level of infection in most of the mosquitoes in the intervention clusters. And here's the control clusters. And you can see that, believe it or not, we got a lot of Wolbachia eventually sort of draining in. And the reason why is those clusters are adjacent to each other. So there was a little bit of bleeding in. And so our intervention, to some extent, you could say it's a bit contaminated and probably underestimates the protective power, because in the end, some of the mosquitoes in the control area were treated with Wolbachia. Anyway, here's the final results. And what we're looking at here is the number of participants who had virologically confirmed dengue in the intervention arm and also in the control arm. And the size of the cluster represents the number of people who actually had it. And so you can see here that the intervention, there was very little dengue activity there, whereas in the control area, there was quite a bit of dengue. And they calculated that there was a 77% reduction in infection and 86% reduction in hospitalization. So that was really a strong effect. And we were really pleased about that. And here is looking at what they call a tree diagram. And basically what it shows is this dashed line. It shows the level of protection in a treatment versus a control area, okay? Before and after trial, like we had in Cairns, or actually treatment and control areas, such as we had in Indonesia. But you can see here in Cairns, 96% reduction, Townsville 95, and here's Yogyakarta 76. In Vinh Long in Vietnam, 86%. In Rio, 45% protection, a reduction. And then Niterói, these are an island as part of the Rio area, and there we had anywhere from about 80 to 50% reduction in dengue. So this has been consistent in areas we've been able to establish it. So there is another way to use Wolbachia. So it's all looking really good, right? Remember from the video that a male that has Wolbachia mates with a wild female, he sterilizes her, okay? So what you can do is you can just release male mosquitoes with Wolbachia and just keep releasing them again and again and again. And they go and they mate with the wild females. And it's sort of in effect a takeoff on the old SIT program, sterile insect technique. And then what happens is you eventually drive the population down. And if you do it hard enough for long enough, theoretically, you can get it to zero. So this has been going, male 80s releases for suppressions have been going on primarily in the United States, but also here in Australia and also in Singapore and in China. And we worked with a group called Verily, and Verily is an arm of Google, Okay, so they had the fancy engineering. They had a van with GPS, automatic stuff, computers, things that shot mosquitoes out, automatic sex sorting machines, because you only want to release males. And yeah, and it was pretty interesting time, wasn't it, Mick? Yeah, well, yeah. And I'm going to show you some results from those trials. Here is a Fresno trial that they did around the same time we were running ours here. And you can see this is control populations. They had 3 different control clusters, and down below are the intervention where they released the Wolbachia infected males. And you can see that there was quite a reduction in the mosquito populations, about 90–95% reduction. But one of the issues with this is if you don't get all the mosquitoes, and as soon as you take your foot off the pedal, then here's one where they were releasing sterilizing males, and you can see the population got really low, and then they quit. And within 1 or 2 years, it was right back where it started from. So what do you do when you get it down at the end? So they still haven't quite sorted that issue out. So we had a trial here in Cairns, here at JCU. We reared the mosquitoes, and we released them in Innisfil, and this was led by Nigel Beebe, and he's of UQ, and Cyril. Cyril was heavily involved too. And here were the areas. We were down near Innisfil. We had 3 treatment areas in red, and then we had control areas in white. And they're small little communities. They might have, 500 houses, so nothing that huge, but they're isolated. So this graph is good. There's 2 things going on in this graph. I did not make this graph, okay? I pinched this graph. Thank you, Nigel. Anyway, so the populations here where there's overlap, it means that they're about the same. And the treatment is this sort of reddish. The treatment area, the mean of the 3 treatment areas, and the control are the blue. And we can see as we got into the releases, and this sort of gray thing back here are actually estimated number of mosquitoes that were released. So we started around here, and then we paused for a while for reasons I can't go into, and then they started again. But the thing you can see in the top graph is that the population starts separating here. So the treatment population becomes significantly less than the control, which is what we want. And this graphic down here shows you how much, if you're on this dashed line, that means they're the same. And so you can see that they were more or less the same. And then once we started releasing mosquitoes, they went down to much less. And this is one particular area that really worked good. This was Marillion. And this was a year after we quit releasing mosquitoes. Because remember how I said they can bounce back. Here they were down here. This was the control area, okay? And so there were almost no mosquitoes there. In fact, they didn't catch mosquitoes for several weeks. And then it started slowly picking up. Now, one thing to keep in mind, when we released in Marillion, the overflooding ratio was 10 times. So in other words, we released 10 males for every 1 female that was out there in the wild. So that's a good advantage. And that's what you want to have. You like to be up around 10. Whoops. Okay, here's the other ones. It's a busy, messy graph. And we are looking at the solid lines. And the thing you can see, it's not as good as Marillion. In fact, at this one place, South Johnston, it's basically come back right to normal within a year. And then in Goondy Bend, it's maybe a little bit less than it used to be, but it didn't work as well there. And probably the reason is they figured that our overflooding ratio in those areas was only 5 times. So we didn't release enough mosquitoes. So we were wondering with our Wolbachia program, how do we scale up for mega cities? Well, one thing we were going to do, I was going to move to Panama. We were going to open up a Latin American hub, and we were going to really expand and go big. I was all ready. We had stuff in boxes, different color codes. My wife had quit her job. I had quit my, I was moving on. And I even have a Guy Bear shirt. I got my Panama hat. I was all ready to go. Then this hit. And I saw an article that said, when did the penny drop for you about COVID? And this is when it dropped for me. I was at a cafe, a lovely little Italian cafe, hole-in-the-wall place in Melbourne that weekend. I wasn't going to the footy like our prime minister wanted to do. But anyway, I'm in the toilet, I'm looking at the ABC News, and I see this damn thing. I said, Jesus Christ, Peter Dutton got COVID from Ivanka Trump. Oh, it's all over now, mate. And we got out of Melbourne just in time because they locked down, I think they locked down within the next couple of days. So anyway, so what happens when it locks down? What do you do? So what happened with me? Well, things changed. One thing, I didn't need a Panama hat anymore. So I started having this thing, an old daggy thing, and we started doing Zoom. I don't need a Guy Bear shirt anymore. So basically, I could sit around in any old daggy t-shirt. And the good thing is, at least at home, you wouldn't have to worry about what you were wearing underneath because nobody could see it. But I'm not going to drop my drawers for you, okay? But anyway, you've got time. So it was Zoom meeting after Zoom meeting after Zoom meeting. And one of the things I did was I got into birds. And it was really fun. Now, this is a lovely fairy wren. It was taken right over here at JCU on that service road that comes in. It's a beautiful animal. And so I've been out here. In fact, there's a couple of birding friends of mine sitting right here in front. So it's a good thing to do. Get you out, get you away. Beat zoo. What about WMP? What happened to them? Well, I don't have any slides to show because I could get in trouble. But basically, we went on pause at the very beginning for a couple of months where basically nothing was done in the field. And then in places where they were already releasing, they geared back up and started releasing again. But then in those places, if they had another, we had places in Colombia and Brazil where dengue really went, where COVID really went ballistic. So they had intermittent lockdowns. And they're still having intermittent lockdowns right now. We've got a release program in Vietnam, and everything there is on pause right now. So it's been really difficult. So everything is, while work has been done and releases have been completed in some areas, it's not been without its problems. And also I would say that the people have been very heroic. There have been instances where almost all the staff members know someone who has had COVID or has even died of COVID. And quite often staff would get infected with COVID. And then of course, other staff that were around them, you had to quarantine and stuff. So it's been very, very disruptive. And so, we've been developing plans. I'm tired of SOPs and strategic documents and stuff like that and Zoom meetings. So everything carries on in its own weird, warped sort of way. But we're still moving forward. And dengue will be there. So that's more or less the talk. I want to thank you and Tess and Yoko for that. And Nigel Beebe and Cyro Vector Team, JCU, Public Health Entomology, Eliminate Dengue in the World Mosquito Program. And Nigel Snowden, the Verily Dengue Program. Because one thing is, once COVID does relax and go away, we get back to normal, dengue will still be there. In fact, it'll really ramp up as people start traveling. So I know here we are into down the hatch. We have our nibblies and our drinks. So the rainbow bee eater says it's time for down the hatch. But until then, questions? Any questions? I should have planted some. There you go, Tom.
Thanks for that, Scott. Very entertaining. My question was related to Brazil. What do you think the main reasons are for the Wolbachia reductions and preventing dengue there?
Well, a couple of reasons. One, they weren't releasing high enough numbers of mosquitoes. There was pressure. Remember when the Rio Olympics came on? So they went big, and they probably weren't really ready to go real big. But there was political pressure to go and do all these releases in Rio. And we figure that we need to release at least 2 mosquitoes per person. And our overflooding ratio should be at least 1-to-1 and preferably 2-to-1 over natural mosquitoes. And they just didn't have the numbers that they were releasing. They also were doing adult releases, and they've had a strange way of releasing adults. The guy he had this little narrow tube of adult mosquitoes, and he'd go stick it out in the car and go. And I've got slow-mo video that shows the mosquitoes just going bam, 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 just getting smashed in there. And I thought, that can't be good. And finally, there are areas in Brazil where it's really tricky to get into and do stuff, the favelas. So one thing is, someone did mention drones. We have done a trial of drones in Fiji and Suva, and it worked pretty good. So drones are on our radar too, and might be especially good in areas where it's really hard to access. Yes, sir.
Is there
for the people on Zoom?
what do you think the risk of like Wolbachia resistance developing? Is that a risk that's there, or is that like, for instance, as the foot is taken off the gas?
Yeah, good question. It comes up all the time. I guess there's 2 ways of looking at it. Will mosquitoes become resistant to Wolbachia? And with that drive mechanism, where in the males, it sterilizes the females, that's a pretty potent drive mechanism. And as long as the Wolbachia doesn't have too much of a fitness cost on the mosquito itself, and we figure the fitness cost of the strain that we're using is only about 20%. And we've also looked at the genomes of mosquitoes, these infected mosquitoes that have been out in the field here for, several years. And I think they only found like 4 changes in the genome. So there isn't a lot of change going in the Wolbachia. And we think, it's fairly stable in these areas. The one weakness of this particular strain, it's a strain called WML, is that it is susceptible to heat. So if it gets over 35, 40 degrees, it starts dropping out of the mosquito. And if you get it where it's too far reduced in the population, then it'll just entirely disappear. And we have seen that in a couple of test spots. But there's other strains of Wolbachia that are heat resistant. So that's one thing. We started with one strain, everything looked really good. And now people are looking at new strains. They're creating new strains, particularly Ari Hoffman's group is working with another strain, WLB, that is heat resistant. And they're doing work in Malaysia. And we've used WLB in Mexico too, where it's hotter. The other form of resistance would be dengue virus itself. So maybe dengue virus would reach the point where it would be able to get around the parasite in the salivary gland tissues. That could happen. And, it's just like any intervention, there is that chance that resistance could evolve. It does with pesticides. Maybe we get 20 years, 30 years out of this stuff, but that's pretty good.
We've got a question on Zoom, so
Yep.
if you'd like to unmute and ask.
Zoom.
Oh, hi, Scott. It's Dennis. How are you, mate?
Dennis,
Yeah.
what do you
look,
know?
As a member of our wonderful little ornithological group in Cairns, and seeing that tabita, of course, with its insect in its mouth, I wonder if you or the group have ever had any reflections on the impact of collapsing. I know it's an odd thing to say, but collapsing mosquito numbers, i.e. the diminution of insects worldwide. So if we were to eradicate mosquitoes, whether it be dengue ones or whether it be malarial ones, has there ever been a discussion on the impact that might have on our wonderful avian world? What do you think?
Dennis, that's a good. I'm not going to talk to the speaker. I'll turn around now. I hope you can hear me. It's pretty weird, but anyway, that's a very good question. And you know, I wondered what the role of mosquitoes are in some of these birds, and particularly the birds that go into places like the Arctic tundra with early spring. And in fact, they may feed on the masses of snowmelt mosquitoes that breed in those areas, the larvae. I wouldn't be surprised. And that one guy, that Irish guy who was going to come up here, but couldn't because of COVID, the guy who's involved in BirdLife Australia, I heard him on the radio and he said he thought those things fed on mosquito larvae. And they might. I've never seen any data on this. So, but look, I would think in most cases, most birds really like to feed on a nice fat moth, something bigger than a mosquito. And most mosquitoes are pretty good at avoiding things like they don't fly way out in open air to where they're going to get nabbed by the mosquito, by the birds. So I don't think it would have a huge impact, but I do wonder if you did eliminate mosquitoes in those areas like the tundra, Arctic tundra, it could have an impact. Now, the good thing is no one's doing anything about those mosquitoes up there because hardly anyone lives up there. Reindeer live up there, caribou live up there, and our curlews, et cetera. Shorebirds live up there. So I think they'll be okay.
Yeah, well, we hope so anyway. Yeah. Thanks, Scott.
You bet, mate. Wolbachia doesn't kill mosquitoes. That's my thing, other than to sterilize. They're still there. No pesticide is used in this intervention.
I think that's all the questions on
Okay.
Zoom. I think that's all here. Thank you.
You bet. And if anyone wants to look at a couple of these, feel free to come on up.